This is a quick guide into the biological process of sporulation. Some microbes have adopted the defensive measure of sporulation to protect their genetic material from extreme heat, toxins, and radiation. These endospores are also able to germinate during an almost indefinite amount of time. A cell's first step in sporulation is asymmetric cell division. DNA replication occurs normally, but rather than normal binary fission, a spore septum forms to separate the new spore, the forespore, and the mother cell. The mother cell then proceeds to engulf the forespore through phagocytosis. At the beginning of engulfment, the spore coat begins to form. Between the inner and outer layers of the spore membrane, a layer of peptidoglycan forms called the cortex. This thick layer of peptidoglycan and proteins protect the genetic material from extreme temperatures. The inner layer of the spore membrane protects the DNA from radiation. Then, the mother cell lyses to release the mature endospore. The spore's coat gives it protection against heat, radiation, toxins, and mechanical stresses. Eventually, receptors on the spore coat detect a suitable environment by detecting essential molecules called germinants, which signal germination. Spores can be dangerous for humans as they are not easily detectable and can be consumed through food or picked up in open wounds, only to germinate later in the body. But spores are an important biological tool. One theory about how life began on Earth is that a meteor carried spores from another planet to Earth, as endospores can survive even in space. Also, endospores could be useful for developing vaccines and supporting the biotech industry in the future due to their use as recombinant materials. Thank you for watching, and we hope you enjoyed.